Hello again and welcome to a new video of Rubber Ducky. Here, in this video, I should write the determinant function, and also, if I get the time, I would like to write a few more, like the min function, the max function, and a few others, like mean, or I should call it average, because it sounds just like the minimum, and the STD. So let's begin with the determinant. Public not void, but double. The determinant is a number that comes out of a square matrix. So public double det. Let's return something for now, and let's think about what's going to happen. So if we don't have a square matrix, there's no way to get a determinant out of it. There's no definition. So what I would like to do in that case is to ensure that the dimensions of the matrix match. So I write this, and in case that the matrix is not rectangular, I should do something like throw an exception, like give not a rectangular matrix. But if I'm not mistaken, this will give me an unreported exception, which must be caught or declared to be thrown. What I do in this case is there is probably another class of exceptions that I can invoke. So the kind of exception that I need to throw is a runtime exception. So this does not need to get catched or declared to be thrown, since it's going to be thrown at runtime. All I want for now is that if someone asks to the determinant of a non-rectangular matrix, he should throw that kind of thing. Also, this block of code or a similar one should be put in various other different points in my code, because I have to check further conditions. Now, how to calculate the determinant? I would like to do it, since I went all the way to define the submatrix function, I would like to do it recursively. So what this means is that if I'm going to write the recursion, first thing I need to do is to write the case where the recursion ends. So if m equals to 1, return this dot get 0, 0. So if this matrix has a single element, then return the value of the element. In a different case, what should be done is the following. We pick int, let's say it num, which I will define as 0 for now, and I will do for I int I equals 0, I less than this dot get m, m I plus plus. I will have to return the sum of the submatrices of this column, so I'll call it column, and I will have a running sum, double sum, or sum or anything similar, initialize at 0, and what I'll do here is that running sum plus equals this dot get I column times the determinant times the this dot submatrix I column dot determinant. So it's quite a recursion over here. Column. And I think this is the correct way to do it. So I think that in the case of a singular matrix, of a matrix with a single element, this will return the value, which will be then, in a case of 2 by 2 matrix, I have to put the plus minus here, times math dot pow minus 1 to the power of I comma I plus column plus 1, or plus 1, or since it's squared it's I plus column, so if it's 0 0 it's gonna be minus 1, so I think it's plus 1. The easiest way to do it is to try it out and see what happens, but for now, so let's get first the simplest case, which would be not the simplest, well, the simplest would be this matrix, which would return number 1 or number A. So in case of a different matrix, like a 1 2 3 4, it would go like this. For column 0, it would take this column and go for all the lines, m lines, rows, not lines, rows. So the 0th column, the first line and the second line, it would search for it would get this determinant, it would get this, this, with the sign of 1, so 0 0 minus 1 0 0 to the 0th power should be 1, times the determinant of the submatrix, which is 4, which will return 4, and then it will add 0 1, the sign will be minus 1, number 3 times the determinant of 2, which is 2. So actually this matrix has a determinant of 3 minus 3 times 2, which is minus 2. I should expect to see minus 2. And return the running sum. Let's see if it works. I'd be surprised if it does. So a matrix, let's create a different matrix, the one that we did, the one that we said, the one that we defined earlier, like a two-dimensional, a 2 by 2 square matrix, 3 and 4. X is the new matrix mate, x.show, and system out print line x.det. Do you work? Not the rectangular matrix. What? What the heck? Why not? Well, obviously it's a rectangular matrix. So, well, did I write this code? Am I so careless? Anyway, let's do this again. And minus 2, it's correct. And maybe I should put away this little thing in here. Yeah, good idea. Anyway, let's see. Will I get a determinant for this? Not a rectangular matrix, of course it's not. Let's make it. How about now? Well, 0. 0. Well, I should not be surprised. There is a pattern here. Something must mess things up and make the matrix with a determinant of 0. But let me try something else. So, triangular matrices have the neat property that their determinants are the product of the diagonal elements. So 1 times 12 times 23. I'm too lazy to figure that out, so I'll go like 12 times 23, which is, yep, calculates it right. So proud of my code. That should be a 7 over here. And yeah, so this is it. It works like a charm. So let's move on. I think it's time for the next video. And in the next video, we will finally go to the statistical part of this series. Thanks for keeping up with me. See you next time.